This is the Dyna-MoCap final review video for CIS 563, physically based animation. I'm Bobby, my partner is Naren. Let's get started. So the motivation behind our project is motion capture is great as far as getting believable animation quickly and easily. It's used a lot in games and videos, movies, animations. But the problem with those is that they don't change. When you have the motion capture animation, you can, hit the character with a ball or punch them or kick them or something, and it does not react in any way. They're static. So what we wanted to do is to still have the believable animation that motion capture gives us, but allow it to have dynamic response so that it responds to the environment around it. And our approach is based on the paper Dynamic Response for Motion Capture Animation. And there's a second paper, Interactive Dynamic Response for Games, which basically modifies that for real-time performance. We initially stated that we would try to do that if time was permitting, and time was not permitting, so we did not get a chance to do that. Algorithm overview, basically what you do is you start out with playing the motion capture, and then you get some sort of impact on it from the environment. Getting hit by a ball is what we use, or it could be kicked or punched by characters, what they used in the original paper. So when you get that impact, you take that impact and switch over to a physical simulation, and using that you do a first simulation. And then using that first simulation, you search through a database of potential motions and select the one that is closest to that simulation motion. And once you have that, you create a second simulation using a PD controller, using torques on the character's joints in order to move it as close as possible to the selected motion. And once you have that, in order to ensure that it blends smoothly, you blend from that second simulation into the selected motion, and that gives you a nice smooth transition, and then you are in a new motion capture motion that you play like normal. So our implementation, we wanted to focus on the novel parts of the paper, which are steps 4 and 5 basically of the algorithm. The problem with that is we could not find a good framework that already had the first 3 steps all together in one place for us. So what we ended up having to do was combine a couple different frameworks, and then we had to spend a fair chunk of time getting those two to work together and basically get those first 3 steps working. And then once we did that, then we also did steps 4 and 5. So as far as the frameworks we used, we started out with Carnegie Mellon's motion capture player and Simicon. Basically we used the motion capture player to read in the ASF and AMC files that we used for the motion capture. And then once we had that, we basically transferred over the data to a heavily modified Simicon, where we basically used their user interface and physics engine integration and then kind of did our own thing within there. As far as what we completed, based on the work plan that we initially set out, we successfully completed stage 1 and stage 2, which were basically the implementation of the first paper, Dynamic Response. We did not have time to implement the interactive dynamic response for games, which would have given us real-time performance, but we had to spend a bunch of time getting our frameworks to work nicely and everything, so we did not get a chance to do that. As far as things that could still be done to improve our project, there's some things that we could do to improve the results of our current stuff. The original paper had some, I think 100 some odd motions within their database, they said. We do not have anywhere near that, so obviously having more motions within our database would allow us to get better motions as far as matching what the simulation is doing. And then also we could probably spend some more time experimenting with parameter changes as far as the distance metrics and the blending MPD controller things go in order to improve things a little bit there. And then the paper also states that their blending technique is kind of rudimentary and would probably actually break if you had a not very close match as far as the motions go. So we could probably make that a little more robust, so that if we do get poor matches, then it doesn't just look bad. And then the other thing that we could do is look at improving performance, because it's not the fastest thing in the world at the moment. So there's a definite pause as it searches through things and everything. So I mean, there's probably general performance tweaks that we can make in our code as it is, and then we could then implement the interactive dynamic response paper as well in order to get real-time results. And now after this, we are going to show you the result videos that we have from our project. Thank you very much.